Martin, you're presenting your Licentiate thesis today. So can you give us a short background about what was the main objective and motivation for your research work?
Yeah, so first of all, the title of the thesis is A Step Towards the Design of Collaborative Autonomous Machines. And this was more or less then coming out of a lot of research initiatives we are doing within Volvo Construction Equipment already, where we try to automate a lot of our machines. And right now the trend is towards automating existing machines, but I would like really to focus a little bit more on automating tasks instead of machines. And therefore a design principle is needed to come up with new solutions, new designs of machines. And here I guess that is a small but first step into the direction of really designing new types of machinery that can be then utilized in mining and construction.
So what have the more specific in the industrial cases been about that you've been working on?
So the focus for sure is, since I'm coming from construction equipment OEM, and the focus had been on construction and mining, and therefore especially in the area of raw material extraction, how we call it, or quarry and aggregates, where we think that the automation and also then the autonomous machines will be the first more or less application field, and not so much the general building construction, more really these confined areas where we have a certain control and a certain good overview about the site, and that has been kind of focus for this research right now.
So yeah, what are the main results from your thesis?
The main results are that communication or connectivity, first of all, is needed for a really sufficient automation of the different systems. So let it be the machine itself, so that we have to have a really good connectivity between the different subcomponents on a machine level, and then also going away from the machine to the overarching systems, that information needs to be exchanged. But on the other side, then also the communication towards other machine types, and especially towards humans. That is really, really essential to make autonomous machines being applicable in a work environment. And here, especially the facilitation of trust through communication. That was one of the main findings I did, or I found during the research.
So in terms of your sort of concrete contributions, I guess your main contribution to the industrial practice so far, or what would you say that is?
Here I think when we usually starting with designing machines and utilizing the knowledge we have in the company, then we have a huge, more or less, data set we can make use of. But when it comes to the design and development of autonomous machines, nobody has a really good understanding or a data set we can rely on, and therefore I think just the first steps towards this and methods how to do, for example, need finding when it comes to the design and development for autonomous machines, that I would say is a contribution I can say I started with. And for sure it needs to be sketched out much more, but at least we did the first steps, and they're looking promising.
We talk sometimes about the autonomous machines being collaborators. How would you do need finding with robots?
Yeah, though that's a tricky part right now, since we don't have too many examples out there where we just can go there and, or you cannot go there and ask. That is the trickiest part. So what we did in the research was that we learned from existing collaborations. So human-to-human collaborations is something where we can utilize a lot of insights already for designing appropriate communication interfaces or interaction styles for the autonomous machines. And that is part of the need finding we are doing, that we say, okay, we just can do traditional need finding, but the focus is on the future type of machinery. So here, that is the take we followed in, especially the last part of the research in the Licentiate.
Mm-hmm. You present an interaction model as one of your main sort of conclusions or findings. Why is that what is that, and why is that an important thing for the future?
So interaction model, I would say it's important because it's describing more or less all the different interactions that can happen around an autonomous machine, and it is needed just to, in a theoretical manner, sketch out all the possibilities autonomous machine has to deal with in its application area. And for us as a research group, it is also then creating a possibility to create a kind of digital representation. And here we then can model more or less all the interfaces that are going into the autonomous machine, but also going out. And here we have then the possibility to develop and design concepts in a simulation. And then based on the promising ones, we can then go for real physical prototypes and test our assumptions. And so here kind of existing interaction models are not known so far, and especially for the autonomous machines, and here that is just the initial one, and for sure the redefinition and refining is needed and will be the next step in my research.
Mm-hmm. So if we take the more academic contributions, what would you say is the contributions so far to the kind of academic development and within the research field that you're working within?
Here I would say it's also coming down to how needs and requirements for autonomous systems can be developed and can be utilized and captured. So since it's not really something that is available today, on an academic perspective, there needs to be a possibility to go out and map all these requirements. And here I think that was a kind of nice academic contribution, that we already started figuring out how this can be done in a kind of existing environment, but still having this ambiguity of an autonomous future in mind.
Mm-hmm. So if we take more your experience from actually doing the research and doing the licentiate phase of your research, what's been the sort of most your personal learning outcomes? What has been the most interesting so far?
So the most interesting part was that there is a lot of work going into such a small thesis here, and for sure it's in the beginning it seems to be a big mountain, but just looking back, it's not that big anymore. The biggest challenge was then to keep within the frame that was given by the supervisors, to not have too many I would say blah blah in the thesis, just to bring it down and pinpoint these are the findings, these are the contributions. And the really interesting part was that in the end it was all coming together, and that is something I was not seeing from the beginning, and that was quite nice experience.
So if you would start this journey over again, what would you do differently given your experience now?
So I just recently mentioned that I would start a little bit earlier with maybe with writing, and but that is just a kind of personal reflection. But on the other side, it's for sure knowing what I know right now. It would be going a little bit deeper into what is available today, maybe sketching out also other industries a little bit deeper, all the automation solutions that are available so far, and then creating a bigger state-of-the-art chapter. That would be nice. Not knowing if this would be necessary, but it would be definitely add more meat to the bone, and so could be beneficial.
Mm-hmm. So what's the best advice you would give to a new PhD student when they would start their journey?
Yeah, I would say don't be too stressed about publishing all your work. It's more getting the work done, and then take your findings and write it down and present it. So here it's really about finding a good case and showing that you're contributing to a real world problem and not just doing a kind of theoretical approach to something nobody really cares. Here that is, I would say, a really nice experience that actually the research I'm doing is well received by the company, by the research group, and therefore that is something also a new PhD should focus on, that maybe the direction is not only given by the supervisors and the examiners, it's also his one per decision what to take.
What would you say in terms of what your results? How could this be applicable from what you've learned so far if we would take this to education, for instance?
Yeah, so since education is usually very focused on pumping the theory into the students and just a little bit of practical exercises, I really would like to see students going out more and exploring these real world problems and solving them in kind of early stages. It don't need to be kind of big stuff like we are working on in the research group, but just the small parts and exploring and going a little bit deeper into the need finding, and then really get a sense for the small bits and pieces and understanding, okay, these are the pains of the users and this is the stuff we can make a difference. That I think would be something I can maybe bring in to the education, and then also utilizing these results in from the autonomous machine perspective with the ambiguity. That would be really, really interesting to teach the students how to utilize that.
Okay, thank you.